Welcome back to the course. And today we're talking about the chi-squared test. This is a statistical test that will allow us to back everything we've been doing so far in Tableau. So all those A/B tests and classification or categorization tests that we've been doing, they've been very intuitive. And we've always said that sample size matters, but we're not checking it per se, and it's not a proper statistical test, but it's very visual at the same time and fast. So it's kind of a trade-off. It's been a trade-off so far, but today we will actually talk about the chi-squared test in detail, and that will allow us to be more confident about the things we're doing in Tableau, those intuitive things, and especially when we're explaining them to somebody, we'll be confident that we are saying the right thing and that this is in fact the outcome and these are the insights. So let's get straight into it. This is the plan for today. First of all, we're going to identify the problem. We're going to look at an example from our previous Tableau manipulations. Then we will talk about what is a chi-squared test and how it can help us solve that problem. Then we'll look at another example, example 2. Then we will actually run chi-squared tests in Excel. So I will show you how to build a chi-squared test in Excel, and moreover you will get my template. You'll be able to download it so you can follow along and create the same thing, or you can just download my template and follow along that way. And also we will verify the chi-squared results using an online tool. So I'll show you a couple of online tools where you can verify the results, which are very it's a quick way to get the outcome of your chi-squared test. And finally, we will talk about the chi-squared rules. And also I haven't put it in here, but I will give you a challenge to take away home for you to practice a chi-squared test. Okay, let's get straight into it. This might be quite a long tutorial, so although it is quite an important one if you want to be 100% certain that you're talking about the right thing. All right, so we had a look at gender in our course so far, and there was a split between female and male, and we saw that 25% of females exited the bank in the period of observation from that sample of 10,000 people, and only 16% of males left the bank, right? So the question here is, and this is where we identify the challenge or the problem. The question is that a statistically significant result? Can we say for certain that females are more likely, or female customers are more likely to leave the bank than male customers? Or did this happen just by accident? Did this observation randomly happen, and that difference between 25 and 16, even though we can see it in our sample size, in reality in the population it's not going to be as visible, and in the whole population of the bank there's no difference. Whether it's a female customer or a male customer, they have the same likelihood of leaving. So that's when we need to run a chi-squared test. The chi-squared test will tell us if this is a random coincidence or this is in fact a statistically significant result that can be applied or extrapolated onto the whole population of the bank. So in order to run a chi-squared test, this is an important part that you have to remember, that you cannot use percentages. You have to change percentages to the absolute figure. So we're going to go back to our absolutes, and this is what it looked like in absolutes. As you can see, there's less female customers than male customers, and the exited value numbers are presented there. So now let's put this information into a table. This is what it will look like. This is the observed table. This is what we saw, the number of male and female customers that stayed and exited. So you've got the categories as rows, and you've got the outcomes as columns. That is the conventional way of representing a chi-squared test, a table for a chi-squared test. Now in a chi-squared test, there's a second table that you need to create, and that table is called the expected table. I'm going to use my mouse here because it's pretty important. So you've got a total of male customers. You take these two, you add them up, and it gives you a total number of male customers, right? And that'll be about just over 5,000 customers. Now, if you take these two, the total number of exited, and you add them up, it'll give you about 2,000. And we know that there's a total in this whole table. The total is 10,000. So 2,000 divided by 10,000 gives you 20%. 20% of people exit, right? So now this expected table, what it represents is if there is no dependency. So if leaving the company, the decision to leave the company is independent of gender, then what we would expect is that 20% of males leave and 20% of females leave. Makes sense, right? So if you know that 20% of people overall leave the company from this sample size, then it should be the same for males and females. It should be 20% here and should be 20% here. And that's exactly how you create this table. So you calculate 20% of the total males, you add up the males, you get the 20%, and then whatever is left, those are the ones that stayed. And whatever went, for females, same thing. You add up, then you get 20% of that, and whatever is left, those customers decided to stay. And that's what we expect to see. This is what we saw in reality. Now, if you look at these two tables, they are quite different. So the expected value here is over 1,000, here is below 900, here is the opposite, it's just above 900, here is over 1,100. And so what the chi-squared test will do for you, it will tell you, is the difference between this table and this table a random difference, or is it a statistically significant difference? So by default, we say that the difference is not statistically significant, it's just a random coincidence. So pretty much we're saying that this table is just like this table, plus minus some little random error which we can discard. What the chi-squared test allows you to do is it allows you to rebut or disqualify that hypothesis and say that actually this is a statistically significant result. So that means the chi-squared is a test designed to test the probability of independence. So we're testing whether our variable that we're looking at, so exited, is yes or no, is it independent of gender? That's what we're testing. We're testing the probability of independence. And that's important to remember. Now, let's look at a second example before we continue on to Excel. Here we've got has credit card. This is another test that we ran in Tableau, and here you can see that it doesn't look like there's any difference, right? It doesn't look like it makes a difference whether or not you have a credit card or not. You pretty much, like 20% of those who had a credit card exited and 21% of those who didn't have a credit card exited. Okay, so from Tableau, we can kind of see that intuitively. Now, if you move to the chi-squared test, we have to get rid of the percentages. We have to go back to absolute values, which is important. We have to create the observed table, which looks like that. So we just put in these numbers in there. We have to create the expected table, which we know how to create now. So we take the total number of people who have credit cards and multiply it by 20%. That will give us this value. And then whatever is left is the people that stayed. So the people that we would expect to stay. And the same thing for people who don't have credit cards. This is 20% of the total that we have here. And that's everybody else. So what I wanted to highlight here, from here we're going to move to Excel. But before we do, I wanted to highlight to you that in Excel we're going to get some result, and like it's probably going to be not statistically significant. So meaning that there is no difference whether you have a credit card or not. But from here, what you can see is that in this chart, right, and in these tables overall that we're preparing for the chi-squared test, it's all very complicated to see this. It doesn't scream at you, doesn't tell you like, hey, this is not a statistically significant result. But when you look at the Tableau result over here, you can see that it is pretty obvious that there is no statistical significance. Like, without going into too much detail, you can say that I'm not 100% certain of the result, but I can see that most likely there isn't any statistical significance here, and it's just a random kind of coincidence that these are a bit higher than these. And that is the beauty of this approach, this framework that I'm showing you in Tableau, that you can do that so quickly. You don't have to run the full test every single time just to visualize these things. Anyway, so let's move on to Excel. I'm going to end this show. And I'm going to bring up Excel, and I'll show you how to create the test. So here I'm going to zoom in a little bit, and then I'm going to say chi-squared test, and let's create our table. So the first table is the observed table. Observed table, right? So I'm going to just copy the data. This is going to be for our 1 second. So this is going to be this data that I'm going to copy for gender. There we go. And now what I'm going to do is I'm going to add up the records, right? So maybe let's take observed and put it there. I'm going to add up the records. I'm going to say alt plus plus gives you the sum, alt plus plus, alt plus plus, alt plus plus, right? And then just do another alt plus plus. So now we know there's 10,000 records in here in total. There's 5,400 males, females, and that's the people who stayed, that's the people who exited, right? So we've created the observed table. Now let's create the expected table, right? So it's going to be similar. We need male, female, stayed, exited, but this is going to be a calculation. So it's very simple to create in Excel. You go equals, and you look at the people who stayed, right? And you divide by the people overall, and then you multiply. So that's your percentage of people who stayed. Then you multiply that by the number of males that you have in total, equals. So here, what we want to do the same for the rest of them. But in order to speed things up, we're just going to lock some of these cells by clicking F4. We don't want this one to move ever. Then with this one, we don't want it to move. We don't want the number to change, so we'll lock the number. And with this one, we don't want the column to change. We always want it to be in column D. So we'll lock the letter. Click OK. And now if I copy it here, as you can see, it's already done everything for me. It's looking at the percentage of people who exited. So this column divided by this column, or this cell divided by this cell, multiplied by the total number of males. So there you go, 111,000. In our expected table, we had a bit of a different value, but that's because of rounding errors. Because we took 20% by default. Here it's a bit different to 20% in reality. So let's copy this one here. Just check. You see that it's doing the same thing. Percentage of stayed times total females. And here, same thing. So we're taking exited divided by 10,000 and multiplying by total females. There we go. So one more time, alt plus plus, alt plus plus, alt plus plus, alt plus plus, alt plus plus. So here you can notice that this value is the same as this value. It doesn't change because total number of males doesn't change. It doesn't matter how you count, right? And total number of females doesn't change. But what does change is the proportion of stayed to exited in each one of them. So here you can see that it's different to that. Here you can see that it's different to that. But once again, these don't change. So the total number of exited didn't change. The total number of stayed didn't change. That's a good quality check for you. And here you have 10,000 people. Here you have 10,000 people too. So last thing that we need to do is check the p-value. So p-value will basically tell you if what the chi-square test, what result it's giving back to you. So we're going to say equals chi test. And here we want the actual range. As you can see, actual range is that, comma, expected range, which is that. Click enter. And as you can see, p-value is very small. It even had to use a mathematical or scientific term. So that is a 10 to the power of minus 26, a very small p-value. What you need to check is significance level, right? So we're going to say our significance level is 0.05. What that means, without going into too much detail, what that means is that this is basically 5%, which is saying that what is the probability that what is our cutoff probability that we want to check that this is a random result. So basically we want to say, let me show you on an example. So if p-value is less than 0.05, then we will say not random. Otherwise we will say independent, right? Independent. Okay, so what this is telling us is that, So what this is telling us is that because the p-value is less than your significance level, that this is not a random result, that what you're seeing is some sort of correlation, that the result, stayed or exited, is actually dependent on your variable, which is gender in this case. If, on the other hand, the p-value was greater than 0.05, then you would be able to say that the result is random, meaning that your variable here is not dependent on age. So I'm going to save this. I'm going to wait 1 second. I'm going to just bring up my visualization section. I'll just save it here in advanced data mining. And this will be chi-squared. All right, so now what I would like to do is take the values for the stayed and exited in terms of the has credit card. So we'll copy these values into our test and see how that goes. So I'll just copy them here, and then I'm just going to copy the values without the formats, and then I'll get rid of these two. All right. So here what you can see is a different result, right? Here you can see, well, we have to change this. This is going to be yes. No, don't forget to change that. So here we can see that this is our observed, and this is what we were expecting. And the p-value here is 0.47, so it's huge. It's a massive p-value, 47%, 47.5%. Once again, we're not going to details of p-value. We're just using it as a flag or a trigger for us, I guess. So then this is what the chi-squared test spits out. And since it's greater than the significance level, which is 0.05, here you can see that the result is independent, meaning that our variable stayed exited has nothing to do with whether or not they have a credit card or not. And once again, so I'm going to bring up the presentation now. Once again, here from Tableau, we could see this right away. We could tell 21%, 20%, not a big difference. Like you can't really tell from here or from any of this, but from here you can totally tell. And once again, you can run the chi-squared test just to make sure that you're on the right track. All right. So now what I wanted to show you is an online tool, how to run the chi-squared test. There's our online tool. So let me just move this to credit card. And you just, this is the website. I like this tool, evanmiller.org/ab-testing/chi-squared.html. So you put in your successes here, say in this case 613. Out of our total trials, okay, that's a good question. What are our total trials? So our total trials here is, so 613, there we go, and total trials is 2945. And here you've got sample 2, you've got 1,424, and your total trials is 5,631. No, I'm sorry, this is actually 7055. There we go. So what does the test tell us? No significant difference, right? So we put in our values just like here. Basically what it did, it just ran a chi-squared test for us. No significant difference. P-value, what is a p-value? 0.48. What did we get? 0.48. Exactly the same p-value. And we can do the same for gender now if we like. So if we just go back, there we go. So male, female, let's do the same thing. 898. Here is going to be 5457. Here it's 1139. 4543. So sample 2 is more successful. Don't look at that, which one is more successful. In our case, it's the opposite because we're looking at exited as the success. But what you can see here is that p-value is tiny. We get a tiny p-value and the result is the same. It's not random. So here you can see that it's not random as well. So that's how you run the chi-squared test. We're running out of time. I'm going to end this tutorial now, and in the next tutorial, I will show you, I'll sum up on the chi-squared and I'll give you an exercise to take home. And I look forward to seeing you next time. Until then, happy analyzing.